Thank you for the invitation. I heard it just 20 minutes ago, so I've made an extended preparation for this one. Normally I'm getting too used to speak a lot, so normally I've got to get off the podium. Someone has to take care for that after 30 minutes. This morning I was speaking with APS for 4 hours. I've made a summary of it, but when you want to stay 4 hours after now, that's no problem for me. What you see there is the new Tesla climate control, and I'll start my introduction about Tesla because it's an autopilot. And then the next question is it possible to control the climate and control your crop completely automatic without interfering of a grower? And the answer is yes, it's possible. But the problem with the autopilot are two things. Do you know? The autopilot is, first you have to keep on the hands from the steer. And the second thing is that you don't have any possibility to use the brake or the gas handle. And the third thing is more difficult. When you are used to it, you get asleep. And that is the problem. So what I've made is not completely a Tesla. It's in research. Yeah? So it will be not tomorrow in the shop for Priva. I think I'm always very optimistic. I think next year, at the end of the next year, then it has to be there. But I will first start to make some tests how it works. And what I want to introduce to you is the principle of the control. And the principle is a little bit different than what you are used to. Because I don't talk about the surrounding of the crop. I talk about the crop itself. And so that's the reason that I got a certain name inside Priva. That's like this one. I'm not talking about equipment. Priva is a technical company for automation. Makes computers. A steer fantastic. But they don't talk a lot about plants, and I do. This is a trivet, and you see there I'm coming in. They are a little bit afraid of me, and most of the people are afraid when you're talking about plants, about crops, and how to integrate them in a computer. So when you're looking for the last time, then you see the crop in a different way. You see that you can grow tomatoes more traditional. You can grow without daylight, or you can grow more in a biological way. And yeah, everyone is thinking, yeah, but my crop is more specific. I have a special crop. You are all tomato growers, I believe. But when I'm talking for sweet pepper growers, sweet pepper is different with tomato, and tomato is different with the orchid, and a rose is also different. And I look more from a plant crop point of view, and then you see much more similarities in a crop. So when you're looking for the crop, you want to do something different with the crop, and that makes the control different. But when you're looking for more the generic aspect, yeah, then you have to control the tomato, and then you have to look for it as a crop. So when you're looking for the greenhouse climate, and for the last 30 years, then you see that we are controlling growth factors like temperature and light, humidity, carbon dioxide, airflow. But yeah, when you're looking for these numbers, for the temperature, the light, humidity, carbon dioxide, it tells something about the surrounding of the crop, not about the crop itself. So this morning I asked some of the growers, do you know exactly what has to be the temperature at 12 minutes after 3 o'clock? Do you know it exactly? And when you know, is it a problem when it is half a degree more or half a degree less? No. But when you're looking for the set points in the computer, they are calculating rather accurate what have to be the temperature there. But do we know for sure that this is the ideal temperature? The second problem what we're looking for, and that I will point out more directly, that is that when you're talking about production of tomatoes, you're talking about kilograms in a week. The crop is developing in time. There's a certain adaptation in time. When you're talking about temperature, there's nothing about time. And every grower knows that when you talk about 20 degrees and 80% in the morning, it's something completely different when you have the same temperature at the end of the day. And the second thing is that when you're looking for a certain level on temperature, I'm not completely convinced that there is an optimal temperature or an optimal humidity. And that is what I want to try to explain with 3 examples. When I'm looking for this one, this is a greenhouse, and then we are talking about the way of control, what we are doing now. We're talking about 20 degrees, relative humidity is 80%. When you look for dark circumstances or the night, what's happening? You are using your heating. The heating is heating up the air, and the air is heating up the crop. So that means that the crop have to be a lower temperature. We are controlling on 20 degrees and 80%. Then the sun is coming through, then it is exactly in the opposite. The sun is heating up the crop, comes 21 degree, and the next step is that the crop delivers the heat to the air. So we have two circumstances. We have put in the set point for 20 degrees and 80%, but when we look for the crop point of view, the difference is 2 degrees. And already in the 90s, the 90s was known, or is known, that when you're looking on crop base, and you look for the development rate, that 1 degree more means that the development rate will be shorter. So it takes less time to develop a leaf. So that will be 1 degree less, but it means that it will be slower, 10%. So when you're looking for this time of crop, both grown at 20 degrees and 80%, the crop at the right side is developing 20% faster than the crop on the left side. We are controlling on temperature, 20 degrees, 80%. We think that we can adjust the crop by adjusting the temperature, but when you're looking for the effect on the pipe temperature on the crop, that is completely different when the sun is involved and we have achieved the same circumstances. So this is the first problem. We are controlling the surrounding of the crop, but the effect on the crop is completely different. Second one, when you're looking for the water balance, yeah, and then I get quite, because there's a lot of discussion of the next generation of growing, close the fence, yeah, pipes down. What happens? So what makes it different? Now, when you're looking for this situation, the temperature is 20 degrees. I'm using my heating pipe, and the fences are slightly open. Then I can choose that, yeah, because of the heating pipe, it gives a lot of airflow, the plant will transpirate more, and at the same time, when I open the fence, the plant will also transpirate more. Then in the second situation, when I close my fence, and there is no heating pipe, the uptake of water will be less, and then the transpiration will be less. So I have a certain balance inside the greenhouse. I have 20 degrees, 80%. I can make a choice for less airflow, less transpiration, and I can make a choice for more transpiration, more water flow. What would be the most ideal situation? I don't know. The only thing what I know, that is when you're looking for a crop, that normally about 10%, 50% of the water uptake is transferred into production, is in dry matter content. So that is what is used for the construction of the plant. What I say, how much water do you have to give? Yeah, at the moment that the plant is only transpirating and not using the water for the construction of the plant, yeah, then you have to make it less. But for the goal, more in general, you want to have the maximum production. So when the dry matter content is constant, then you have to give as much water what's possible. At the moment that the Brix number is decreasing or your quality is decreasing, then you have to slow it down. But when you're looking for the circumstance, in both situations, the plant is in balance. When I give more water and the plant is transpirating more, it's no problem. The only thing what you have to concern about is about the quality. So what you see here, that is as well for the first situation as for the second situation, that is that the flow is much more important than the temperature itself. Temperature itself gives no guarantee that you have the right product. You have to look for the process in the plant and what the plant is doing with transpiration and construction. Yeah, this one, this is what I always use to test the students. I have two situations. I have 20 degrees Celsius and 80% relative humidity. The second situation is 20 degrees and 95. My popular question is, what crop will transpirate most? Oh, what are we thinking that will transpirate most? Then we're looking for the humidity, and then we think, oh, it's 20% more. So we have 20% space of transpiration. In this case, it's rather saturated. But then what can you tell about it? It's almost nothing. Because at the moment that I have this situation, but there is no air exchange around the leaf, then there will be no transpiration and the crop is standing still. We're looking for the outside climate, but we have to look what is happening very close to the leaves. But when there is no air movement and no exchange of water or exchange of carbon dioxide, the plant will stop with growing. In this situation, when the vents are open, and I talk here about that the velocity is about 2 meters per second, but I mentioned that it is 2 times an hour, then you see that the plant will transpire. And of course, when you make the circumstances exactly equal, so when you say, okay, I use the same vent position here and there, then this one will transpire more. So when you look for the temperature and the relative humidity, it's not only important that you look for temperature, relative humidity, but at the same time you have to look what you are doing with your equipment. Is there more air movement, more air exchange, or less? And I have sometimes the feeling that we're only looking for the numbers on a sheet and looking for the tables, but we don't take account what is happening with the air exchange or with the air movement inside. According for me, I think that the flow, and to control the flow, control the transport is the most important fact. So when we're looking for the crop judgment, and we're looking for the crop, then we look for factors as development rate, what is happening with the length grow in the week, what is growing state, to call it vegetative, generative, what's happening with the sugar content of the fruits, with the Brex number, and then we look for the crop, and then we have a lot of experience and intuition to control it. Yeah? So that is what is happening now. But when you're looking for the process, already in 1732 there was a person, Linnaeus, and he described already that when you're looking for a crop, that all the things could change on the crop, the leaf, the flower, the stem, the roots, but when you're looking for the only part of the flower, what is not, what makes not, the difference, what is not influenced by abiotic facts like temperature or water, that is the male part of the flower. Oh, I have to go back here. So that is the pollen, here 2, 3, 4, and so on. I make an old-fashioned joke always that you see there are 24 at this moment. Linnaeus has made a mistake, because you see here that the female part is also to it. Yeah, that's a mistake. Always when women are involved, then it goes, yeah. But when you're looking for the first 21, it's okay. This is still the systematic to make a difference between plants, to order the plants in families. So the only thing what is changing is this one. This was described already in the introduction in 1732, that it was very difficult to classify plants based on what you saw, because most of the plants were influenced by the water balance. So what you see in practice, we're talking a lot about light, and I won't deny it. Light is important for dry matter production, but when you're looking for the morphology of the plants, burning tips and so on, and disturbances, it is all to do with the water balance inside. So when you're looking for the crop, we have to look for the water balance. You can see it on the leaves, on the stem, on the roots, on the flowers. And when you're looking more exact to the flowers, the ground number of a flower for a tomato is 5. And here you see a little bit a disturbance of the plant, and it is caused because the plant is standing a little bit too vegetative. What is the reason? Gets too much water, is standing too wet, and then you make 6 flower leaves. And the ground number is 5, so you can see on the flower rather accurate what is happening. But in my opinion, most of the disturbances, what I see in practice, due to climate and due to water, has to do with the water balance, not with the light, water balance. Yeah? And of course light is influenced, because when you have a lot of light, you have a lot of cells, and then you need more water and so on. But the disturbances in water are, according for me, the most important one. Now here you see one. Now, I have not so much time, only 10 minutes, 15 minutes. Yeah. Here you see what happens when the relative humidity is too high, when there is a stagnation of transpiration. And then you see the confusing about relative humidity, because at the moment that there is stagnation of transpiration, it is in most of the cases due to a high relative humidity. We make that connection. But it could also occur when there is no air movement, and you see the same type of leaves. But here you see all those little bulbs on the leaf. So this is what's happening on the leaf when there is not enough exchange of water vapor from the leaf. So in this case, when you look at more accurate and you can compare it with the other situation, in this case it was caused that there was not enough ventilation in the morning. So And what was the reason? Close the vents, because the vents are closed, because temperature is low, and we are waiting till we can open it. Then we have the air movement, and then it starts to transpire. But when you are waiting too long, then this one is occurring on the leaves. This one is also happening. In this case, you have too less air movement, so this is due that the plant can't rid of it, but this is the problem that when there is too less air movement, the plant makes scutation, and you get drops on the leaves, and then you get this hole because the drops are evaporating again, and then you get that hole. Both are due to a high, when you read it in the overviews, in a high relative humidity. But mostly reason is, the most important reason is that it is due to the airflow, that there is not enough air exchange possible to get rid of the water vapor. So when we're looking more exactly, we're looking for the water in the plant. What is needed by the plant, it's about 10%. But you see, when you are making calculations, about 5 till 25% of the water is used for the construction. And what I now try to do in the new control is that it is constantly a fixed number. Could be 10%, could be 50%. That is due to the quality. When you have more dry matter, the quality will increasing. When you have more water, and you have more production, less water, then the quality is better. But that is a choice what you have to make. But I try to make it as constant as possible in time. How I do it? I measure the leaf temperature, and the leaf temperature, the plant has to be able to cool itself down. So there has to be a constant transport of water. Now this one I started with 4 years ago. I was measuring the air temperature, I measured the leaf temperature, and then I was looking for the trend in time, what was happening with the leaf and with the air. So the plant has to follow the air in time. That is what is most important. When the plant is not able to transpirate, the temperature of the crop will increase, then you get fluctuation in the crop temperature, and then you get problems with your quality of your leaves and with your fruits. But when it is stable, you are able to do so. This was what I presented about 1 year ago, I think. Yeah. And in my opinion, and then you see what happens when you are innovator for Priva, I'm innovator. And that means that when you make a mistake, then you try it in another way. So I was already busy with my 8th attempt to get the concept rolling on, And then I said, when I want to make a feedback control, use the camera on the leaf and look for the difference in temperature and then try to make a control, then you have to measure rather accurate the temperature of the leaf. What happens in practice when you have a measurement on your leaf? Someone is walking around, is picking tomatoes, up. The camera is not pointing on the leaf, but on the heating system. Now, when your control is depending on that difference, then you get slightly a problem with your control of your fence and everything there. So it is possible to control, but then you have to check your camera. I thought, no, 1 time a week, no, not enough. 1 time a day, not enough. Every hour. Was possible. Every hour you have to check and to control the camera on the day. Instead, sometimes someone is walking around and half an hour you could have the wrong control, but I recognize this is not suitable for practice. This is not what I can do. And the second thing, what I did, I looked for the measurements and I know exactly what have to be the curve, what have to be the outcome. So I was looking for the measurements. The girl was phoning me. I saw very strange measurements in the crop temperature, and I said, you have to check the camera because the curve is not corresponding what I expect. November this year, I did it in the opposite way. I make a curve, and I'm steering according to the curve, and then you see the big difference with the practice, and that is what I want to point out now. That is the new state, and that is what I started with in the Netherlands, with 10 companies, and hopefully also in England. I do it in the opposite way. And this is what is behind. I don't steer on temperature, relative humidity, but I steer on velocity. Now, what you see here, this is 1932. It's quite long ago. This man is Heisenberg. I don't think you know him because he was on the German side. But he was scientist, so scientists have not a political idea. But he was very clever. And this is Niels Bohr, you know him, he's from the They contacted with Rutherford and with Einstein, all friends together, yeah, living in different countries. But his proposition was the next one, and that is what I've used also for the new control. You can look for a level, and you can look for a flow. But you can't control them both at the same time. So what are we doing now in practice? We are grower, and we are controlling on a level. We want to achieve 20 degrees. When it is getting too cold, what are we doing? We're putting in a heating system. But what is happening with the heating system? The pipe is going up, and what happens with the heat flow? It becomes more. At the moment that we have achieved the temperature, the heating pipe is going down, means less flow. The same you can say from when it is getting too warm. What are we doing when it is getting too warm inside the greenhouse? We open the fence. So what happens with the air exchange is increasing. To maintain a certain temperature, if we open the fence more, you get more air exchange. So at the moment that you are controlling on level, you have no idea what happens with the flow. And now you see my proposition for the new control. Because I think, what I tried to explain, that is water balance and water transport in the plant is the most important fact. I'm convinced of that. So we have not to look for the temperature, no, we have to steer on flow. We have to take care that the plant is able to transpirate and that he is doing it in the right way. And then is the next question, what is the right way for the flow? Have to be constant 24 hours, or is it different on the day and the night, or have to be more fluid? That's the big issue. Now, and this is what I want to present for now. If I have 10 minutes, 5 minutes. This is what we're doing now. This is our control. We have 6 periods. I've made, perhaps you do it in a little bit slightly different way, but we have a night temperature. In the morning we make it a little bit colder, then we go slowly up. At the end of the day, we are higher, so to prevent that we ventilate too much, then we are going. Perhaps I have here pre-night, it's also possible, but this is the way of control. And this is old-fashioned. This is what we did in the 90s, because we have a computer and we have only the possibility to use a night temperature and a day temperature. And we have achieved quite a lot, because now it's possible to use 6 periods. But when you're looking for nature, you see very straight lines here. Have you ever seen in nature something what is with a straight line? I not. I hope so in England, but I don't think so. So when you're looking for this, what is the result of this one? The result is this one. We get this type of control. You see that when you're looking for the temperature, you see a very irregular control of the flow. You see irregular with the temperature. When you're looking more in detail, yeah, this is what is happening with the crop itself. This is light, and when I put a line in it for the sun position, you see it is very smooth. But what are we doing now in the present control? When there is less light, what I'm doing with my fence, closing, because the temperature is dropping. And when I get more light, what happens? Yeah, then I open again. So what you see here, when you're looking more in general, what is the result? This is the result from the day. And then you see that, yeah, when you're looking for the temperature, you see that the temperature is a little bit irregular. Sometimes it's okay, but then sometimes too less, sometimes too much. Next question, this is inside the greenhouse. What happens outside? Plants are used to outside climate. Then is happening this one. And then you see that we do it in the greenhouse better than outside. That's a good thing, because we have to, yeah, I'm automation for greenhouses. Yeah, so I'm happy that we do it better in the greenhouse than outside. So that is nice, but you see still the differences. You see the plant, you see that there is a regularity when you're looking to your eyes, and you see, okay, the movement is there, but now what is the plant doing? We try to steer it in our way with a nice straight line, but the plant is doing like this. And then you see that the plant is following exactly the curve, what you see, yeah, what is according, you can call it sun position, but it's following a curve, it's fluid. So what is the difference when you're looking for this one? How do you have to steer the climate? When I'm looking for the climate here, I'm always too late. Some here I'm too late. I have to move it up, but I'm too late. And the difference in time is about 20 minutes. And that is the time what you need, Yeah, what the plant needs to heat up the air. So what you see, that is that you are too late. You have to be 15 minutes, 20 minutes earlier. How can you do it? Yeah, then you have to give a pre-steering. So when you're looking for this, when you want to achieve this, then you have to do this with your ventilation. So what you see here, I make a pre-steering of my ventilation. That is what you see here. You see that the ventilation at the end of the day is down. I don't talk about have it to be 20%, 40%, 60%, but it is when you're looking for the principle of the plant, it has to be more or less a curve. It has to go slowly up, slowly down. That is the moment that you are helping the plant. Now my difference between my new control and the old-fashioned control. When you're opening the fence in the morning, then you are waiting that it is getting too warm. And only at the moment that you are getting too warm, then you open the fence. I do it in the opposite way. I give a pre-steering on the fence, and then, when it is getting too cold, I close them. It seems to be that for a scientific point of view, you have the same results, but in a practical point of view, you see that the fan control is much more smoother. So when the light is going down, and nothing is happening with the temperature inside the greenhouse, I keep on ventilating. And the reason why is this one. When I'm looking for the crop, this is the crop temperature, you see that there is a lot of fluctuation in light. That is what you saw here. But when you're looking for the crop in this way of steering, then you see that the crop is going fine, that it is following the curve. So we are thinking that at the moment that the light is going down, that we immediately have to close the fence, but the plant is running around, yeah? And it is like an interval in a marathon. When you want to make the fastest time in walking, yeah, then you have two possibilities. You can slow, fast, or you can go it in a regular state. What gives the best result? What gives the best time? That is when you are going around. So what are we doing now with the present control? We are moving up, down, up, down. Yeah, what to do with this type? Is this good or bad? Now, you get a very good condition of the plant. I assure you, interval training, then you make a better quality. That could be, but it is not good for your production, not good for your time. So I think we have to help the plant, and we have to make a pre-steering of the computer. Now how many time? 2 minutes? Yeah. So I'm just in time. What is the meaning of this one? I try to make, you try to make the best crop. You can do it by hand. What I see in practice, and what I've done with the testing out of the program, I've looked what the growers are doing. And then I look from, what are you doing with all those set points, 60,000? And then I see that there is always the same control. And then I turn it around, put it inside the computer, and that you can adjust it more easily. I don't say that it is not possible to grow a perfect crop with the present computer, but it takes a lot of attention. 60,000 set points. You have the possibilities are there. You can do it, but it takes a lot of time. So when I'm looking in practice, and then I have this one. This one is a coffee machine. It takes about 1 hour before I've made my coffee. It's the perfect coffee ever. My wife is not very happy with it because she has to wait for 1 hour. But I can assure you the coffee is the best. She likes more this one. You put a cup inside, you put on a button, and the coffee coming out. Will it always be the best coffee? I don't think so, but you are assured that you will get coffee. Yeah? And instead of waiting for 2 hours or 3 hours, it will be always the same quality. I don't think that it is possible to make an automatic control completely. There is always the grower needed to make the best. But you can make it more easy. So there have to be some equipment just in between this one and that one. And that's my computer for the future. Thank you.